Flack math! Give me some math and I'll give you some flack. Flack math!
So this is the power rule for exponents. Okay, so what we've already learned is the product rule, which basically when we have something like this, x to the second times x to the third, how is that simplified? What is this? X to the fifth. And a couple of you on your last test forgot to do this. That you also need to simplify this. We didn't really do this much because I think the better way is to bring this up here and then simplify it. But you can use the quotient rule, right? So this is the product rule. Product rule, quotient rule. Okay, so if you add these exponents, what do you do with these exponents? Subtract. So this would be x to the 1 or just x, right? Okay, so in your answer, if you have x's over x's, then it's not simplified. It's not reduced, right? So if you have a fraction 6/8, well, you can divide a 2 out of both the top and the bottom. Same thing here with variables. If you have x's over x's, you can divide at least one x, but in this case, you can divide 2 x's out of both the top and the bottom. Okay, so now we're going to talk about the power rule. So we can use the product rule to describe what's happening. Okay, so if this is x squared to the third power, this just means x squared times x squared times x squared, right? That's what the third power means. Multiply whatever this 3 is applying to by itself 3 times. So then what do you do with these exponents? Add them, so you get x to the 6. So what's the shortcut?
You just do 2 times 3.
Yes. So you multiply. So if you have x to the m to the n, this is x to the mn. In this case, this is the product rule, x to the m times x to the n. This is x to the m plus n. And if this is x to the m divided by x to the n, this is x to the m minus n. So using m and n and x, this describes how to deal with each rule of exponents, okay? So here's my young brain in 8th or 9th grade, whenever I learned this. To me, it was like, what? Okay, so you have to, it's like a step down in operations. You see that? When you're multiplying exponential expressions, what are you actually doing with the exponents? You're adding. So multiplication, step down from multiplication is like addition, right? So then when you're dividing, you subtract. So step down from dividing. So like division and subtraction are like long lost cousins. We don't like either. And then like when you're doing exponential expressions, when you're raising something to a power, what's a step down from that operation? Multiplication. So that's how my feeble little mind at that age was thinking about it. And when we start talking about logarithms in Algebra 2, it's going to make more sense that way too. So when you're dealing with exponents, it's almost like you're going down a level. So, and really, all math is just glorified counting anyway, right? So addition is just counting, like you used to count on your fingers when you added, right? Now you have stuff memorized, so you don't have to say 8 plus 5 is 8, 9, 10, 11, 12, 13. You don't have to do that anymore. You have it memorized. Multiplication is just glorified adding, right? 3 times 5 is just 3 plus 3 plus 3 plus 3 plus 3, or 5 plus 5 plus 5. So it's all one step down anyway. And powers is just glorified multiplication, fast multiplication. So that's the power rule. So let's so really these 3 rules of what we've learned so far, okay? So let's try a couple examples, make sure you guys got it, and then we'll move on. Okay, so let's do this. Example A. Feels like we don't really need to practice this, but what is this? A to the 10th. You're just multiplying. Okay, if you forget, that's okay. You can just do what you know. Well, that's just A times another A. How many A's? Did I say A? A. That's 10 A's, right? So you could just multiply it. You could just write it all out, and it makes sense, okay? All right, let's try this one. M to the -2 to the 4th. What's this? Nathan? M to the -8. There's no exceptions. You can multiply negative numbers too. So this is M to the -8. Okay? And then if I said write this with positive exponents, what would you do here? Yeah, put it on the bottom. So I could say or 1 over M to the 8th, right? So remember, negative exponents have nothing to do with whether something's positive or negative. So this is not negative M to the 8th, okay? Don't do that. You got to remember that. This is what I love about Saxon, is because Saxon is going to keep circling around, spiraling around, so you won't forget it. My son is doing Algebra 2 right now, and he's doing another curriculum, not Saxon. And I said, okay, what do you do with negative exponents? Make it negative. And he's good at math. But he just forgot, because it's been a while since he's done that in his math class, in his math curriculum. So I don't like that curriculum. I won't say it on the internet, because I don't want to badmouth another curriculum, okay? But let me just say that textbooks don't teach very well. You need to, so they're not teaching text. But okay, so anyway, let's do another one. What about this guy? Here's example C. C is going to be difficult, I guess. 1 over M squared all to the 4th. What do you do there? Yeah? Yeah, because look what we did. It's really just this. See, M to the -2 is just 1 over M squared. So this is the same problem. So it's just 1 over M to the 8th. Okay, because you still have to apply the exponent to every single factor inside the parenthesis. So let's back up here a little bit and try this. What about something like this? What if I had 2x to the 5th y squared z all to the 3rd power? Well, if we don't know what to do, we can always just write it out. How do we write this out? Just 2x to the 5th y squared z, 2x to the 5th y squared z, 2x to the 5th y squared z. Sorry, I'm getting a little mushy there. And then what is this? What's 2 times 2 times 2? What's 2 times 2 times 2?
Oh, sorry.
8. And then what's x to the 5th times x to the 5th times x to the 5th? 15. What's y squared, y squared, y squared? Y to the 6. And what's z, z, z? Okay, so look what we did here. We kind of did this distributive property of exponents, which doesn't really exist. So don't tell all your friends that there's a distributive property of exponents. They'll laugh at you, okay? So really what we're doing is we're multiplying that exponent by all of the exponents, including this one. What happens when you don't see an exponent? It's a 1. So 2 to the 3rd, x to the 15th, y to the 6th, and z to the 3rd. Okay? So you can still use the power rule for this, even though there's multiple variables and a coefficient, but you have to apply that exponent to each factor. Okay, can you guys handle that? All right, let's try an example. Prove your might. I'm going to erase. All right, let's look at it. Let's see if we can get crazy right away here. 3x to the negative 2, y to the 5th, all over z, all to the 15th. So this is about as complicated as these kind of problems are going to get. Okay, so let's deal with those exponents first, and then maybe we can simplify it a little bit more. We'll see. So see if you can do that one. Please enjoy this music while you work. Courtesy of Elijah Pence and his crew.
You tell me you say all these things after class too.
Okay, what do we got? We have an answer yet? Probably because I wrote down the problem wrong, but we'll go with this one anyway. Let's make it easy. Ready? So let's say that this does have a variable, or it does have an exponent, and it's 0.
Wait, the exponent's 0. Does that mean 3 is gone?
Yeah.
3 doesn't.
This team does not.
Okay, so I'm going in. Ready? So I'm going to multiply this exponent by all the exponents inside, including this one down here, which is just a 1. And I'm going to get 3 to the 0, x to the negative 30th, y to the 75th, all over z to the 15th. Is that what you guys got so far?
Yep.
Something like that? And then what's 3 to the 0? 1. So that becomes a 1, which means it cancels when it's being multiplied by something else. You don't need a 1. So it just cancels. And you're left with x to the negative 30th, y to the 75th, z to the 15th. Okay? Now, if I wanted to write with all positive exponents, I could just bring that x down. Yeah, so you get y to the 75th, all over x to the 30th, z to the 15th. Okay? Is that terrible? All right, now here's why it's not terrible. Because you're in the box right now. Okay? As soon as you start learning the next thing, which is conversions in volume, then you're like, okay, what did we do? How did we do this again? So this is why Saxon tries to stretch you a little bit. It makes you memorize everything all at the same time. So every test in Saxon is what we call cumulative, which means it goes over all the concepts that we've talked about this year. So the first few tests in Saxon are not terrible, right? Because there's only a few concepts you've learned. But when you get to the end of the year, these tests get harder and harder. Okay? So it's good though, because it forces you to remember everything. Okay, so still in lesson 53. You guys want to do one more of this, or you feel okay?
Do one more.
Okay, let's do one more. We won't do a fraction because fractions make me uncomfortable. Let's do this one. Ready? All in parentheses, 2a to the negative 2, b squared, z to the negative 10th, all to the negative 5th. Okay? Do that. See if you can do it in 60 seconds.
What?
60 seconds.
I believe in you. Did you already get it?
I'm done.
Okay. All right, Nathan, what'd you get?
I got 32. A 10, B negative 10, Z 50.
All right, close, but not right. There's one little thing that you did wrong. Somebody get something different?
I got negative 32.
Okay,
Oh, yeah.
close, but that's wrong.
Oh!
A negative 10.
Was it 1 over 30?
So 32 would have to go on the bottom. Remember, negative exponents don't make it negative. They put it on the bottom. Okay? So let's do that. Let's just do it one at a time. We're going to rewrite it with their new exponents. Okay? It's like Christmas for these guys. They get new exponents. It's not exciting. Okay. All right. 2 to the negative 5th. A to the positive 10, because a negative times a negative is positive, right? B to the negative 10, and Z to the positive 50th. So far, so good? If you got that far, you get half credit, no questions asked. That's awesome. But this 2 to the negative 5th, I can simplify that. Well, first of all the negative exponents go on the bottom. But if it's a constant raised to a negative power, that has to go on the bottom. So let's do that. Let's put that down there. And since we're putting that negative down there, let's put that one down there too. Sound good? So what's 2 to the 5th again?
2 to the 5th is 32.
Yep. So I need a 32 on the bottom and then a b to the 10th on the bottom.
I wrote 10. But that's because.
Did you guys get that?
Except for
No.
I didn't get 32 for that because I got 10 because I got 10 because I was doing the thing for the other things.
Yeah.
Confused.
So you got 10 for the constant?
Yep.
Yeah. So so remember, you're not multiplying by the factor, you're multiplying by the factor's exponent. Okay?
I was thinking it was like if you were to write it 5 more times, and
Yeah.
add it.
Yeah. So if you wrote 2 times 2 times 2 times 2, if you're writing this 5 times on the bottom because it's negative, then you would have 2 times 2 times 2, event all the 2's multiplied. Remember, this means you multiply it all together, not add it all together. Yes.
How big would that Z be? Because it's the 50th.
Well, it depends on what Z is. If it was 1, it would just be 1. If Z was 1/2, it would be really small, actually.
If it were 2.
Yeah.
0.
Even with 2, it gets up there pretty quick. Okay, so that's the power rule for exponents. These two are really the hardest is it going to get. So when you're dealing with this is the hardest part, is that 32. Okay, so don't feel bad if you mess that up. Okay, so just remember, put the exponent there and treat this like a variable until you're ready to simplify it. Okay, treat it like a variable. Don't think think of it as a 2 yet. Think of it as another weird variable. And then once you have it out of the parentheses, then you can figure it out. Because 2 to the negative 5th is not 2 times negative 5, right? It's 2 to the negative 5th, which is 1 over 2 to the 5th. All right, moving on. Still in 53 here. We're just going to talk about conversions and volume. Remember when the trick question, and some of you got this wrong on your test, but because you forgot. But how many square inches are in 2 square feet?
Uh, 188.
Yes, 288. Why?
Because there's 2 square feet.
Right. So remember, square feet are the 144 square inches in 1 square foot. Remember, a square foot is like this. If it's 1 foot by 1 foot, that's a square foot. So it's a 12 by 12 inch tile, right? So how many little square inches are in there? 144. So everything's doubled, not doubled, but yeah, doubled. When you're doing unit multipliers, you're multiplying by 12 twice. So everything's squared, okay? So instead of multiplying by 12, you're multiplying by 12 squared. So let me ask you this. How many cubic inches are in a cubic foot? You don't have to tell me a number. You can tell me an exponential expression if you want. How many cubic inches are in a cubic foot? So we're adding another dimension here. How many cubic inches? Yeah.
1,728.
Okay, how'd you get that?
I did 144 times 12.
Yeah, so 12 cubed. Okay, so if you're converting in cubic units, you cube the unit multiplier, or you cube the conversion factor. Inches and feet, that's 12, right? So if there's 12 inches in 1 foot, that means there's 12 squared square inches in a square foot. That means there's 12 cubic inches in a cubic foot, okay? All right, so if that's confusing to you, that's okay, because you can just use unit multipliers. Unit multipliers is a little bit easier to get your head around if that's confusing to you. So for example, let's do 180 feet. Cubic feet equals how many cubic inches? Okay, so how do we do unit multipliers? What's the first step? Put it over 1, make it a fraction. So to make a whole number a fraction, you put it over 1. So now we have to get rid of that label. So we need the feet on the label so we can cross cancel it. But how many feet labels are there right here? This is not feet, this is feet, feet, feet. Okay? So we need 3 of these suckers. So what's the conversion factor with feet and inches? Okay, now some of you on your test did this. You see what's wrong with that? Right, so this is 1 inch does not equal 12 feet. 12 feet is like twice the size of me, and that's not the same thing as 1 inch. Okay? So make sure you put the numbers in the right place. So 1, 12. And now I have enough feet labels to be able to totally cancel that label. So I'm left with 180 times 12 times 12 times 12 times inches times inches times inches. So there's my answer. Okay? You can multiply it out if you want, no problem. But if you show me this, then I know that you know that I know that you know that how to do this. Okay? Yes.
I did not use it. I just multiplied.
Times 1,000 whatever.
Yeah.
Awesome. What'd you get?
311,040.
That's a lot of cubic inches. But cubic inches are cute, right? They're like little sugar cubes. Aw, I love sugar cubes. Okay.
That would fill this room, probably.
What's that?
Are there offers?
Yeah, it would definitely fill the room. Well, maybe,
No.
because this is 10
Yeah, they probably
10
will.
by 8 cubic feet. No, it wouldn't fill the room because this is like a 10 by 8 room. 180 cubic feet, not 10 by 8. Like a 10 by 18, which this is a lot bigger than 10 by 18 room, right? Okay, so let's try one more example, then we'll move on to 54. Deal? Okay, what about this? Here's example 2. 800 cubic centimeters equals how many cubic feet? All right, so this is going to exercise all of our brain power. So unit multipliers is definitely the better way to go because this is confusing. Well, first of all, you can't convert centimeters to feet right away. What do you have to do first? Centimeters to inches. Remember our little diagram over here? So first you have to cross the bridge and then you have to go to the feet town. Okay? So cross the bridge. How do you cross the bridge? How do you get from centimeters to inches? 2.54. All right. So now we just have to figure out where the 2.54 goes and where the 1 goes. So what goes on the bottom? What label goes on the bottom? Centimeters. And how many do we need of those? And then what's our conversion factor? We're getting to inches, right? We're crossing the bridge over to inch town. So 1 inch is 2.54 centimeters, right? Okay, now that's cool, but that's gonna just get us to inches, right? So how do we get from cubic inches to cubic feet? We need to get rid of 3 of those inches labels. So we need unit multipliers that have inches on the bottom of 3 of them. Now we're dealing with inches and feet, so we want to get to feet. So what you're going for, usually if it's just a 1 unit and not a rate, what you want to get to is on top. What you're trying to put behind you, you're going to bury the past, is on the bottom, okay? All right, so what numbers go here? Feet and inches. What will make this 1? 12 inches under 1 foot. So make sure that 1 goes with the 12, or 1 goes with the feet, and the 12 goes with the inches. All right, now we have this mess as an answer, but that's okay. So we just have that 800, and then we have these inches canceled. So now we're left with feet, which is cubic feet, all over 2.54 times itself 3 times. So 2.54 to the 3rd power, and then 12 times itself 3 times. So you can just leave your answer like that. That works. Okay, does that make sense? All right. Okay, let me move on to lesson 54. Okay, awesome. Okay, so we're going to talk about something fancy, the substitution axiom. Basically, the substitution axiom says if 2 things are equal, then that 1 thing can be substituted for that equal thing at any time, right? So if you had a clone of yourself, that would be nice. Like you could Hermione yourself and put yourself in all these classes at the same time. And then whatever Hermione learned in that class, she like understood. So it was like she was there. Well, she was there, right? Well, she didn't really clone herself. What was it? Time travel or something? Yeah. So, but it works the same way in math. So if like A equals B, then B can be substituted in for A at any time. So remember doing these problems where we had xy plus z, x equals 2, y equals 3, z equals 4. So what'd you do? You substituted 2 in for x, 3 in for y, and 4 in for z. And then you were able to evaluate that, right? So this is the same thing. If x equals something, that something can be substituted in for x at any time, okay? All right, so, and usually, like in sports, the sub isn't quite as good or skilled as who they're subbing for, okay? Sometimes they are, I guess. Like, yeah, but sometimes the sub surpasses the skill of who they're subbing in for. But in sports, the substitution axiom is a little different because usually the sub isn't quite as, it's the backup. It's the backup quarterback. It's the backup pitcher or whatever, okay? So let's try this with some actual variables, okay? So if I had x squared y over p, when x equals 2, y equals 4, p equals -1, let's substitute those in and evaluate it. 60 seconds. You can do it, I believe. 30 seconds. Let's do 30 seconds.
What? No. Just a division problem. You don't bring it up when you have a negative exponent on the bottom, you bring it down. What'd you get? What'd you get?
-16.
Yeah, that's what I got. Is that what you guys got? And you didn't shout it out? You just wanted to give him a chance. That's nice. Okay, right. So you're just plugging it in. So you got 2 squared times 4 all over -1. So that's 16 divided by -1. Positive divided by a negative is negative. So -16. Okay. Now this is review. You guys have done this. You actually did this in pre-algebra. Okay. So let's algebra it. All right. So if you have 2 equations, for example, you have 2 equations that are separate from each other. 2x minus y equals 1. And then you've got x equals -3y plus 11. So these are 2, actually, they're linear equations. So if I were to graph these 2 equations, they would be straight lines. Remember doing that? Okay. Now, do we have anything that looks like this? X equals 2, y equals 4, p equals -1? No, but we do have x equals something. Okay? So according to the substitution axiom, we can plug this guy in to right there. Okay? So this is kind of the same thing we did, but on steroids. Okay? So we're going to rewrite this equation with this guy in there. So this is, x doesn't want to be called x anymore. X has got a new cool wrapper name. I don't know. Okay? X is like, yo, I'm -3y plus 11. So Please don't call X X. He's offended by that. So we're going to rewrite this. We have to change the program. So now it's not X anymore. We got to use his new wrapper name. So we're going to substitute the X for this new wrapper name. So this, see how in our minds, this is still 2 times X, right? Because X is the same thing as negative 3y plus 11. If I was a wrapper, I'd probably be called negative 3y plus 11 because that's cool. Okay, minus y equals 1. So see how we just rewrote that equation. That's it. Okay, well, how does that help us? This looks way more complicated than these two equations, right? What's the difference between those equations and this equation? What? There's parentheses, but there's also something a little bit more simple about this. There's only one variable, which means we can solve this. You know, you can't solve this, right? There's infinite number of solutions to these equations, but we can solve this. Let's do it. Negative 6y plus 22 minus y equals 1. Combine those y's, so negative 7y plus 22 equals 1. All right, get rid of the constant term on the variable side. So negative 7y equals negative 21. So y equals positive 3. Well, that's nice. But you say, well, wait a minute. I thought there were infinite number of solutions. Why is there only one now? Well, there's only one y that works in both of these equations with its x partner. X partner, that sounds bad. So they're okay. They're gonna work it out. All right. Okay, so y equals 3. So basically you have 2 linear equations. You have 2 lines, right? Here's my 2 lines. Eventually they're going to cross, and they have one point that they have in common that's on both of the lines. That means there's only one XY combination that works for both of these. Now you could try to just think about it for a while and think about what X and Y works in both of these equations, or you could do it this way using the substitution axiom. So now we've got y equals 3. So if y equals 3, we're going to use the substitution axiom again. Y doesn't want to be called y anymore. What does y want to be called? 3. It's not a very cool wrapper name like negative 3y plus 11, but we'll take it. So now we're going to substitute this guy in wherever we see a y. Well, look at this. I can substitute it in right there. That's the easiest place to do it because now I want to know what x is called. So x equals negative 3y plus 11. Okay? So what is x? Well, that's just negative 9 plus 11. So x equals 2. Now watch this. This is the coolest part. So I'm going to plug in 2 and 3 into both of these equations to see if it works. Well, we already know it works here because that's how we found 2. 2 equals negative 9 plus 11. Let's see if it works up here. What's 2 times 2? 4 minus 3. What's 4 minus 3? It works. That's the only place where it works in both equations. Those lines are not going to come back around and cross each other again. Okay? That's pretty cool. So we deducted that since we had 2 equations, we were able to use substitution to kind of finagle it and manipulate the situation a little bit to where we could figure out and fool this guy into telling us their real identity. Okay? That's pretty fun. I mean, I liked this when I was a kid, but you know, not everyone's like me, whatever. So let's try another example. Okay, so it's nice because X spelled out what it wants to be called now. So this is what it's kind of disturbing and whatever, but you can substitute that in. Even though it's not a nice, pretty little 2, you can still substitute that in. Okay, So here's the rule for equations. To solve one unknown, you need one equation. If you have two unknowns, you need two equations. If you have three unknowns, you need three equations, and so on, okay? All right, let's try another example right up top here. So let's say that, here's example 2. And this is what it'll look like. It'll be like a little brace there, and it'll give you two equations. Okay, so first step, I want you to rewrite this top equation with this value of x, right? Because that's what x equals. It doesn't say x equals 2 or x equals 3, but it does say x equals 3y minus 10. So 3y minus 10, according to the substitution axiom, can be substituted in at any time for x. So rewrite that top equation. I'll be right behind you. Okay, is that what you guys got so far? All right, now follow the steps to solve equations. First step, get rid of those parentheses. Let's rewrite this. What is this? 9y minus 30 plus 2y equals 3. Okay? Then you can combine like terms on the left side. What's 9y and 2y? 11y. Well, what are you subtracting here? You're subtracting 30. So if you're still confused by that, please don't deal with subtraction. So you see how now the 2y, you're not subtracting the 2y. So the symbol that comes after a term has nothing to do with what you do next. Even though that's what's next, okay? If the 2y was right here, then you'd be subtracting a 2y. Okay, so add 30 to both sides. So now my equation is 11y equals 33. Now what? Divide by 11, divide by 11, y equals 3. Okay, are we done? So now what do we do? Plug in 3 for y, right? Where do you want to plug it in? Well, you don't have to plug it in here. You can plug it in anywhere you want, but this is nice because your next step is to find x. Well, x is 3 times whatever y is minus 10. Okay, so see how this is the easiest equation to plug it into. So I'm going to plug in this 3 right there. So x equals 3 times y minus 10. So what's x? -1. Let's make sure it works on that top equation. 3 times negative, what's 3 times -1? -3. What's 2 times 3? 6. So what's -3 plus 6? 3. It works, okay? So here's the cool thing about these problems. You'll never get them wrong. If you check your work and it doesn't come out the 3, then you did something wrong, okay? So give it the time it needs and then you'll never get these wrong, okay? All right. I'm going to just do one more and then we'll call it good, okay? So how about we do this? How about we do a free problem set to whoever gets this first, okay? So Micah, if you want to try this, you don't have your book open, do you?
No.
Okay. So don't look at your book, but if you get this first, I'm going to give you a free problem set, okay? All right, you ready?
We do examples, but then when you do like the free problem set, it's just like the hardest thing. You just write down like 50 different things.
Okay, so Micah, if you get it, why don't you raise your hand? And then I'll be looking at you, and then you can show me on your camera, okay? Your answer. You don't have to do it. It's just for fun. But you get a free problem set if you do it. All right, ready? Okay, here we go. I'm going to make sure I'm not in the way here. Negative x minus 2y equals negative 4. That's the first equation. Second equation, y equals negative 3x plus 8.
It's like you would do 2 plus 10 and you'd be like, all right, this one's for a problem set, and it'd be like 2 minus 10 plus 3 divided by 6 times 10.
Don't look at me like that.
Really,
Yeah.
really confused.
Okay, this time remember, it wasn't x that gave you something. Now it's y that gives you something. So you have to plug all that in for y in the top
It's
equation.
confusing. You don't have
All right, do you have an answer? Where's your answer? Well, no, so that's not right. Sorry.
How many answers do you get? We just like
First one who gets it. So if you didn't get it right the first time, then keep trying.
first one who gets it, or just like
First one who gets it. Yep.
if you get it. I don't
No,
know that
first one who gets it.
there's a time limit.
All right, I don't know.
I got it. Oh, bro, try.
Oh, keep trying.
I'm not understanding this.
Oh, darn it.
What?
I gave you the wrong problem.
Are you serious?
Okay, I'm sorry.
No.
I'm sorry.
Can
So
you
this
again?
is good. You already have a good leg up, but this is not negative.
Oh my gosh.
But what's my
I'm sorry. So try from there. And just because I'm going to give it to the first two that get it, just because I messed up, I'm sorry.
Not gonna read.
Before.
So if you get it,
Okay.
if you're one of the first two to get it, you'll get a free problem set. I apologize. I feel really bad about that. So I was wondering why you guys weren't getting it right away.
That's so much easier.
I don't know where to go from here. We're just gonna go.
There, I think I have it.
All right, don't say it out loud, but show it up to your camera.
There, it's in the chat.
Oh, okay. Nice, Micah. You got it right. So there's one more chance, guys. You can still get it.
I don't get it.
Give up?
I got to the point now.
What'd you do so far?
Everything. But I got I got x squared divided by 2.
So you got something x squared?
Because yes.
All right, what do you got?
Sorry.
Okay, all right, so we got 2 winners. Let's do this together, and then we'll call it a day, okay? So tell me, so I'm gonna just get your progress as we go here. So I'm gonna rewrite this equation down here, negative x minus 2 parenthesis y equals 4. Raise your hand if you did that so far.
No.
Okay, you didn't? What'd you do? Did you substitute it in for x?
No, I put it in front of -2. That's what you did up there. So
In front of -2?
yes, so I put
Oh.
-2 to the right of the parentheses.
Yeah, so see how it's, see how this was substituting something in for x, but this is substituting something in for y.
Well, I could have done that if I, then I would
Okay.
have got the x squared.
All right, so now here's what makes it difficult. Because this is -2 times this and -2 times this. So I think it's easier to chicken scratch. And now you're distributing a -2. So that means plus 6x minus 16. Raise your hand if you got that.
I could have done that.
Okay, good. All right, now what do we do? Add like terms, -x plus 6x, what's that? 5x minus 16 equals 4.
You just
Okay, now what?
add 16.
Add 16.
And then 20 divided by 5 would be
Nice. So 5x equals 20. That means x equals 4. So this is what I'm going to substitute in right there. So now y equals -3 times 4 plus 8. What's -3 times 4?
negative.
-12. So y equals -12 plus 8. So what's -12 plus 8? -4. All right, now you can leave your answer like this, but here's how the cool kids are doing it. 4 comma -4, like a coordinate point. So x is 4 and y is -4. So you can write it as a coordinate. Okay, Nathan?
I got both 5x and I got 20 at some point, but I just didn't.
Yeah. Well, there's a lot of little details.
If I substituted it in the right spot.
Yep.
I put it by x.
So just to be safe, you can do this. -x, well, x was +4, so -4 minus 2 times -4. 2 times -4 is -8. So minus -8. What's minus -8? Plus +8, right? So -4 plus +8, +4. Good job.